what if I told you that you can learn Python in a completely different way than how everyone else is teaching it? Well, most courses have you memorizing syntax and debugging code for months. There's now a method that lets you build real applications from day one. See, most people think learning to code means struggling through endless tutorials and getting stuck on basic concepts. But AI has completely changed the game. Instead of fighting with syntax errors and spending hours on simple programs, you can now focus on understanding concepts while AI handles the heavy lifting. But here's the problem. Nobody's teaching Python this way yet. Everyone's still stuck in the old methods, making coding harder than it needs to be. In the next 30 minutes, you're going to discover exactly how to use AI as your coding partner. We'll start with the absolute basics, variables and data types, but instead of just reading about them, you'll immediately build a working calculator app. Then we'll move through strings and lists by creating a to-do application. And by the end, you'll have built 4 professional projects that most programmers take months to create. The best part, you don't need any prior coding experience. You just need to be willing to learn Python the modern way, with AI as your guide instead of your obstacle. So if you're tired of traditional coding courses that move too slowly, or if you've tried learning Python before and got overwhelmed, this is your chance to finally master programming by using the tools that are actually changing how we code today. Let's dive in. Let's start with one of the most essential concepts in Python: variables. A variable is simply a container that stores information your program can use later. Think of it like labeling a box. You give it a name, you put something inside, and you can open it again whenever you need what's stored there. Everything in programming revolves around variables because they allow your code to remember data, whether it's a number, a name, or even a true or false value. Python makes working with variables incredibly easy because it automatically understands what kind of data you're using. It supports several data types right out of the box. For example, integers or int represents whole numbers like 42, -17, or 0. Floats are decimal numbers such as 3.14 or -0.5. Strings or str are pieces of text written inside quotes like hello or Python. And finally, we have booleans or bool, which are simply true or false values that help programs make decisions. Let's look at a few quick examples so you can see how this works. If I write age equals 25, I've just created a variable called age that stores an integer. If I type price equals 19.99, that's a float because it contains a decimal. Next, name equals Alice is a string since it holds text inside quotation marks. And is_student equals true is a boolean, meaning this variable can only be either true or false. When I run this code, Python automatically knows what each one is without me having to specify the type. That's one of the reasons it's so beginner-friendly. It handles the small details so you can focus on logic and problem solving instead. Variables show up in every kind of program you'll ever build. You might use them to store usernames, ages, or account balances in a registration system, or to track a player's health and score in a game. You can even use them to handle simple math like calculating prices or keeping track of totals. No matter what kind of project you're creating, variables are the building blocks that keep data organized and accessible. Now, let's take this concept and actually build something with it. For this part, we're going to create a simple calculator app using AI to do most of the heavy lifting. Inside Windsurf, I'll open Cascade, our AI assistant, and type this prompt. Please create a simple calculator app using Python. Have a simple GUI for the application. After a few seconds, Cascade starts generating the entire code for us, including the logic for addition, subtraction, multiplication, and division, as well as a clean user interface where you can enter numbers and press buttons to calculate results. Once it's done, I'll run the app, and right away you'll see a working calculator window appear on screen. It's simple, but everything functions perfectly. I can input numbers, choose an operation, and Python instantly performs the math behind the scenes. What's really interesting is that this small project uses exactly the concepts we just learned. Those variables we talked about earlier are what store the numbers we type in and keep track of the calculations before displaying the result. And that's how you start connecting the theory with real-world use. You've learned how variables store and manage different types of data, and now you've seen how AI can help turn that knowledge into an actual working app. In the next part, we'll take it further by working with another set of powerful tools in Python that will help you handle text, collections, and more complex data structures in your programs. Now, let's move on to another core concept in Python, which are strings and lists. These two go hand in hand and show up constantly when you start working with real-world data. A string in Python is simply text written inside quotes. That's it. Any word, sentence, or symbol you wrap in single or double quotes becomes a string. For example, if I write greeting equals hello world, that's a string. Or name equals Alice, same thing. Text stored inside a variable. You can even build longer messages like message equals welcome to Python programming. Strings are great for anything involving words, sentences, or even numbers you want to treat as text, like user inputs or labels on a button. Now, while strings hold single pieces of text, lists let you store multiple items in one place. Think of a list like a container that can hold several variables at once, all organized in order. For example, let's say we have a list of fruits. I can write fruits equals bracket apple, banana, cherry, close bracket. If I want to add another item, I can use fruits.append parenthesis orange. Or if I just want to grab the first fruit, I can do that by calling first equals fruit 0. The number in the square brackets represents the position of the item in the list, starting at 0. Lists are perfect when you need to manage collections of data, things like a shopping cart, survey responses, or even a list of tasks in a productivity app. In short, strings help you manage and format text, while lists help you organize groups of data. You'll often have to use them together. For example, storing multiple messages, handling usernames, or keeping track of items in an inventory. They are simple ideas, but they make your code flexible and powerful once you know how to use them. Now let's take this idea and turn it into something real. We'll build a simple to-do list app that shows exactly how strings and lists work together in a real program. Inside Windsurf, I'll open Cascade, our AI assistant, and give it this prompt. Please create a simple to-do list to showcase the power of strings and lists. Create a simple GUI for this application. Build it in Python. After a few moments, Cascade starts writing all the code for us. It creates a small graphical window with a text box where we can type tasks and buttons that let us add or remove them. When I run the program, you can see it come to life. I can type learn more about Python, hit add, and it appears in the list. Then I'll try to delete this. I can also add study Python, then mark it complete, and just like that, we've got a functioning to-do list app. Behind the scenes, every task you add is stored as a string inside a list. When you remove a task, Python simply deletes that item from the list. It's a perfect example of how these concepts come together to make something useful, wherein strings for the text you see on screen and lists for keeping everything organized in order. So that's how you work with strings and lists in Python. They're the foundation for handling all kinds of structured data, from simple task lists to full-scale databases later on. Every good program needs a brain, something that lets it make choices and react to different situations. Conditionals and loops are meant for this aspect. They're what make your code feel smart, flexible, and alive. Conditionals are what help your program make decisions. You can think of them like a simple is this then that rule. For example, if someone's age is 18 or older, the program might say you're eligible to vote, but if not, it'll say you're not old enough yet. You can see that exact logic written out on screen. It checks the age, compares it to 18, and runs the matching line of code. That kind of check happens all the time in real-world applications. When you log into an account, for example, the program uses conditionals to verify if your password matches. In a game, it might decide whether your health has dropped to 0 and trigger a game over screen. Loops, on the other hand, handle repetition. They tell Python to keep doing something until a certain condition changes. Now, instead of writing the same line of code over and over, you can just loop through it automatically. On screen, you can see two simple examples. One loop that counts from 0 up to 4, and another that keeps running indefinitely until it's told to stop. These loops are used in all kinds of situations, from processing hundreds of data entries to keeping a game running until the player quits. To see both conditionals and loops in action, let's build a small project, a guessing game. This one's fun because it uses both ideas working together. Inside Windsurf, I'll open Cascade and tell it to please make a guessing game in Python to showcase the concept of conditionals and loops. Create a simple GUI for the application. Cascade writes the entire program for us. When I run it, you'll see a small game window pop up where you can type in your guess. Behind the scenes, Python picks a random number, and every time you make a guess, the program checks whether it's too high, too low, or exactly right, all thanks to those conditionals we talked about earlier. And because of loops, the game keeps running until you finally get the correct answer. You can see me trying here to guess the number. I have 10 chances, and it actually took me 9 tries before I finally landed on 88. When that happened, the program instantly displayed a congratulatory message, proving that our condition checking logic worked perfectly. This small project might look simple, but it's one of the best examples of how logic brings your code to life. At this point, your programs can store information, make decisions, and repeat actions. But there's still one big piece missing. You need a way to organize your code so you're not rewriting the same thing over and over again. Here, I'll be introducing you to functions. Functions are reusable blocks of code that perform specific tasks. They are like small machines inside your program. You feed them input, they do some work, and then they give you a result. Let's take a simple example to see how functions are written in Python. You'll see it on the screen. A small piece of code where we define a function called greet. In Python, every function starts with a keyword def, which stands for define. After that comes the name of the function, in that case, greet, followed by a parenthesis that can hold any inputs, called parameters. Here, the parameter is name, which means the function expects you to pass in someone's name when you call it. Inside the function, the code is indented to show that it belongs to that block. There's a single line that uses print to display a message. Hello, name. The curly braces inside the quotation marks are part of something called an f-string. It allows you to insert the value of a variable directly into text. So when you type greet Alice later on, Python takes the word Alice, passes it into the function, and prints out hello Alice. In real-world projects, functions are everywhere. They handle things like calculating prices with tax, checking if an email address is valid, or converting units like Celsius to Fahrenheit. They help you keep your code neat, readable, and easy to manage, especially as your programs start to grow. To see this in action, let's try to build a small project again, a temperature converter app. This one's simple, but it's a perfect way to show how functions actually work in practice. I'll open Cascade inside Windsurf and give it this prompt. Please create a simple temperature converter in Python. Create a simple GUI for the application. Cascade generates the full app for us, complete with input fields, buttons, and labels. When I run it, you'll see a clean little interface where you can type a number, select the conversion type like Celsius to Fahrenheit, and hit convert. Behind the scenes, the app uses a function to take your input, run the conversion formula, and instantly show the result on screen. That's the real strength of functions. They make your programs modular and easy to maintain. If you ever need to tweak the logic, you only change it in one place, and everything else updates automatically. So by learning functions, you're not just writing cleaner code, you're starting to think like a programmer. Every feature, every calculation, every small task can be built as its own function, ready to be reused whenever you need it. Every programmer runs into errors. It's just part of the process. What really matters is how your program handles them. So now let's talk about error handling. It's the difference between an app that crashes the moment something unexpected happens and one that stays calm, gives a friendly message, and keeps running. Error handling teaches your program how to respond when things go wrong. Maybe a user types the wrong kind of input. Maybe a file can't be found, or maybe a calculation doesn't make sense, like trying to divide a number by 0. Without error handling, your program would just stop and crash. But with a simple structure called try and except, Python can catch those errors, understand what went wrong, and react gracefully instead of breaking. You can see on screen an example where Python tries to divide 1 by 0, something that normally causes a crash. But because it's wrapped inside a try except block, the program instead prints a clear message saying it can't divide by 0, and everything keeps running smoothly. In real-world programming, this makes your apps much more reliable and user-friendly. You can think of error handling as a safety net that keeps your code from falling apart when users do something unexpected. And trust me, users always will. To really see how it works, let's make a small project together. Inside Windsurf, I'll open Cascade and tell it, please create an age verifier app to showcase error handling. Create a simple GUI for the application and use Python. After a few seconds, Cascade builds a simple app with an input box where you can type your age. After running it, you can see that if I enter a valid number, the app works just fine. It verifies the input and moves on. But if I type something random like symbols or letters, instead of crashing, the app immediately catches the mistake and displays a message that says it can only accept numbers. That's error handling in action. It's your program staying calm under pressure. The app doesn't just stop or close, it explains what went wrong and helps guide the user to fix it. This is a small example, but every serious application, from simple tools to full-scale platforms, relies on error handling to stay stable and user-friendly. So with this, we've covered the most important fundamentals of Python: variables, lists, loops, functions, and now error handling. These are the core building blocks of every program you'll ever write. From here, we'll move into the next stage where you'll learn how to work with files, use external libraries, and even connect your code to real-world data using APIs. When you write programs, everything you do, the data, the lists, the numbers, only lives in memory while the app is open. The moment you close it, it's all gone. To keep information saved for later, we can write it into files instead. In Python, you can easily store data in text or CSV files, then load it back whenever you need it again. This is how programs remember things like user preferences, saved notes, or logs. It's the bridge between temporary data and something that lasts. Let's start with text files, which are the simplest type of file to work with in Python. You can see on screen how we're using a special command called withOpen. This tells Python to open a file, do whatever we need to do with it, and then automatically close it when we're done. When we open the file in write mode using W, Python creates the file if it doesn't already exist. Inside that block, we use file.write hello world, which writes the text directly into the file. Once that's done, the file is saved to your system. To read it back, we just change the mode to R for reading. Using the same withOpen structure, Python opens the file, and we call file.read parentheses to fetch its contents. That result is stored in a variable called content, which we then print out to the terminal. So in just a couple of lines, you've written data to a file and read it back, something you'll do often in real-world projects. Now let's move on to CSV files, which are great for handling structured data like tables or reports. You can see on screen that we start by importing a library called CSV. When we open a file in write mode again, this time with W and a small extra part new line equals code to keep the formatting clean, we create something called a CSV.writer. This object lets us write rows of data easily. In our example, we're first adding a header row with a column names name, age, and city, followed by 2 rows of actual data. Once that's saved, we can switch to reading mode again, this time using CSV.reader. The code loops through each row in the file and prints it out in the terminal, showing that Python can easily extract structured information from the file. It's a simple but powerful way to work with data, especially when you're handling things like reports, user lists, or even small databases. Working with files like this is incredibly useful. You'll use it in real-world scenarios all the time, saving user preferences that persist after closing the app, logging errors or events for debugging, exporting reports that can be opened in spreadsheets, or even storing game scores locally so players can continue where they left off. Let's put this into practice with a quick project. We'll ask Cascade to build an app that can generate files for us automatically. Here's the prompt I'll use. Please create a file creator in Python that can generate CSV or text files based on the user's input. Have parameters where the user can choose between which file type they would like to have and a section where they can input data based on the file type they've selected. Create a clean, modern GUI for the application. Cascade generates the app within seconds, and when I run it, you can see how everything works. The interface is simple. There's an option to choose between text or CSV, a space to type your data, and a button to create the file. Let's try both options. First, I'll create a text file, and the app instantly generates it with the exact content I typed in. Then I'll switch to CSV mode, enter some structured data, and once again, it saves correctly. This small project demonstrates the core idea behind file handling. Beyond simply saving data, it allows your applications to create, manage, and retrieve information that stays available across sessions. Now, if you've ever looked at a big app or website and wondered how did they build all of that from scratch? Here's the secret. They did it. Developers rarely reinvent the wheel. Instead, they use libraries, which are collections of pre-written code that make complex tasks simple. This is like a toolbox full of ready-made functions you can pull from whenever you need them. For example, on screen, you'll see a short snippet where we import something called pandas, one of Python's most popular data libraries. Pandas makes it easy to organize, analyze, and visualize data without writing hundreds of lines of code yourself. Just one line. Import pandas gives your program access to everything that library can do. In this case, the code simply checks which version of pandas is installed, but that single import unlocks a whole world of functionality. Libraries exist for almost everything you can imagine. Need to generate random passwords? There's a library for that. Want to plot charts or track financial data? There's one for that too. You can use libraries for advanced math, fetching live data from websites, analyzing text, or even building entire user interfaces. They're what make Python so powerful, because no matter what you want to build, chances are someone's already written the hard part for you. Let's try it out in a real project. I'll open Cascade and give it this prompt. Please create a personal finance dashboard in Python that uses pandas, matplotlib, datetime, and JSON/CSV. Make the GUI elegant and responsive. Cascade immediately gets to work, pulling in all the right libraries and connecting them together. After a few moments, we have a full finance dashboard. You can see here that I'm adding a new expense, say groceries for 100, and it instantly appears in the dashboard. Then let's try to add income, which is salary, for $2,000. As you can see, it is also here in the dashboard. Behind the scenes, Pandas handles the data structure. Matplotlib creates the graphs, datetime timestamps each entry, and JSON or CSV manages how everything gets saved. This is the power of libraries. You don't have to build every feature from the ground up. You can focus on logic and design, while Python's ecosystem does the heavy lifting. The more libraries you learn to use, the faster and smarter you'll build. If you've ever used an app to check the weather, book a flight, or see stock prices update in real time, you've already seen APIs in action, even if you didn't realize it. API stands for Application Programming Interface, and it's basically how different software applications talk to each other. Think of it like this. If your program wants information from another source, like a weather website or a payment system, it can't just go in and grab it directly. Instead, it sends a request through an API, and that API responds with exactly the data your app needs. Clean, structured, and easy to use. APIs make the digital world connected. They're what allow your app to pull live information from the internet and integrate external services with just a few lines of code. You can see on screen a simple example of an API call that fetches weather data. The code connects to an open source weather API, sends a request asking for current weather based on specific coordinates, and then prints the result. What's happening behind the scenes is pretty cool. Python sends a request over the internet, the weather service processes it, and then returns a live JSON response containing all the data we asked for. That's the basic structure of almost every API interaction. The use cases for this are endless. You can pull real-time weather updates, fetch news headlines, check stock market data, connect to social media, process online payments, or even trigger notifications through text or email. Once you understand how to make an API call, you could extend your app beyond its local data and start interacting with the whole internet. Let's make this real with a quick project. I'll open Cascade and type in this prompt. Please create a simple weather application in Python. Use known free APIs for weather data and have parameters for the application where the user can input locations to view the weather in real time. Create a modern GUI for the application. After a short wait, Cascade finishes generating the app. You can see here a clean and functional weather interface. Let's start by typing in a city name, let's say Washington. And just like that, the app connects to the API, fetches the data, and displays the current weather instantly. Let's try another location, maybe Los Angeles or Singapore, and the results update right away. This small project shows how important APIs really are. In just one prompt, we built an app that interacts with live online data, and that's something you can apply to almost any kind of project, whether it's finance, travel, gaming, or productivity. APIs are what make your applications smarter and more connected to the world around them. By now, you've learned the foundation of Pythons, from variables to APIs, and seen how AI can speed up the learning process. So let's take it a step further and actually build things. We are going to create full Python applications using Claude Code, an AI coding assistant that can turn plain English prompts into working software. Usually, I'm doing traditional hands-on coding tutorials, but since we've already covered how each concept works, we're letting AI handle the heavy lifting this time. We'll go through 4 different projects, each one designed to highlight what Python and AI can accomplish together. We'll start simple with something useful, a password generator. It's the kind of tool you've probably used before. Quick, practical, and a perfect way to get familiar with Claude Code's workflow. I'll open Claude and type, please create a random password generator using Python. Create a simple GUI for the application and give the user some parameters to select that can influence the generated password. Claude instantly builds everything. A small app with sliders, checkboxes, and buttons where you can customize password length, include symbols or numbers, and generate unique passwords with just one click. After testing it a few times, we've got a simple yet fully functional password generator, all built from a single prompt. This is where it starts getting interesting. Once you see how easily the AI structures everything, it makes you want to push further. So let's do exactly that. Next, we'll build something that actually interacts with the web, a job web scraper. This one introduces us to Beautiful Soup, a popular Python library used to extract data from websites. It's a bit more complex, but that's the fun part. We'll see how AI handles a real-world use case. I'll prompt Claude with, please create a simple job web scraper in Python. Use Beautiful Soup and get job posts from LinkedIn without having to log in. Create a modern and clean GUI. After processing for a few moments, the app is ready to go. When I search for Python developer roles in New York, the interface fills with results, job titles, companies, and short descriptions, all neatly displayed. What's amazing is how seamlessly the AI connects to everything. The logic for fetching web data, the clean layout, and even the filters for searching specific roles. The password generator was about automation. The web scraper, that's all about information, how to collect and organize it automatically. And now that we can work from data from the web, let's make something that can talk back. For our third build, we're going to create an AI chatbot, a program that uses OpenAI's API to have natural, dynamic conversations. Before we start, we'll need an API key from OpenAPI. You can generate one by signing in, creating a new project, and heading over to the API key section. I'll name mine Chatbot, and for this demo, I'm giving it full access so we can test everything smoothly. Once that's ready, I'll tell Claude, Please create a simple AI chatbot in Python using OpenAI. Here's the API key. Insert key here. Please create a modern GUI to complement the chatbot. Claude puts everything together, from the API connection to the chat interface. When I run it, the chatbot immediately responds in real time. Here, you can see me ask it for help with some homework questions, and it replies naturally, like a true AI assistant. It's interactive, intelligent, and surprisingly human-like. We started with a password tool, moved to web automation, and now we've built a full conversational AI. So for the final project, let's make something that lets us visualize all the data we've been working with. Our last project is a data visualizer, a sleek application that turns numbers into charts and graphs. It's the perfect way to bring everything full circle. I'll open Claude again and prompt it with create a Python visualizer that uses matplotlib or pandas. Please create a modern, visually appealing GUI that can take the user's data, whether in the form of a CSV or manual input, and translate that data into visualizations of the user's choosing. A few minutes later, Claude delivers. The app loads with an intuitive interface where you can upload a CSV file or manually enter data. I'll test it with a small dataset, and within seconds, I'm generating clean, professional-looking charts. Bar graphs, pie charts, line graphs, all customizable with a few clicks. The visuals update instantly and everything feels fluid and responsive. It's a perfect finale because it combines everything we've learned: data handling, user input, visualization, and of course, AI automation. From generating passwords and scraping jobs to chatting with an AI and turning data into visuals, we now have a complete set of Python applications, all using natural language prompts. Honestly, seeing all of this come together really shows how much easier coding gets when you can just work with AI instead of against it. We didn't overthink the code or stress about small details. We just built things one idea at a time and let the AI handle the rest. It's a totally different way to learn and create, and it actually makes coding fun again. So that's it. You just learned Python in a way most people haven't even tried yet. You've seen how much faster and more enjoyable it is when you focus on ideas and let AI handle the rest. This is the future of learning to code, not memorizing, but creating. We've already gone from the basics all the way to real working apps, and the crazy part is, this is just the beginning. Once you get comfortable thinking this way, there's really no limit to what you can build. Hey, thanks for sticking around till the end. I'll see you in the next one.